Hi guys, welcome to my YouTube channel. So from the extension of mass action law that we saw in the last class, so let's pause the video and try to answer this question. So they are asking about the Hol's concentration, which is nothing but the P. So here you can check two things, whether the mass action law is valid or not, and then you can proceed. Actually in this case that they haven't mentioned any about heavily doped or anything. They given normally as a concentration and the other parameter, so you can directly use the mass action law. In the case they given anything like a degenerated or non-degenerated, then we have to carefully go through the question. So pause the video and try to answer. So if you guys got the answer, then comment the answer in the comment section. So I will solve the answer that we know from the mass action law. The formula is this. So we need to know about the Hol's concentration. So Ni square, which is 10 power 20. So 10 power 10 into a whole square, that will be 10 power 20. Then divided by n value is 3 into 10 power 12. So 1 by 3 into 10 power 8. So that will be the answer. So if you guys get this answer, please comment, and you guys are in a you can congrats yourself that you are in a same phase aligned with me. So from this explanation, we getting into another one important topic, that is nothing but the electrical neutrality condition. So we know that Nd is a donor atom, that is a donor concentration atom. So donor atom concentration. So donor atom concentration. Then Na is the acceptor atom concentration. Acceptor atom concentration. Okay. So there is a charge neutrality condition that need to exist in every physical or in a real world scenarios. So how the charge neutrality applied is, let's see. So Nd, that can be written in a term of Q into Nd in order to make the charge neutralized. So Na, the acceptor atom, we can refer it as minus Q times Na. So this is the charge neutrality for these two things. Normal N can be charge neutralized into minus Q into N. So this is some reference value. So we already discussed one reference in a diffusion, right? So this is second reference. Make a note of it. So here the reference value will vary for Na and N alone. So here that will be plus Q into P. So this is the charge neutrality for P and Q. So in the ideal real scenarios, how these values need to be there is that, so in the case of let's take an PN junction diode, then the charge density, we can relate this to be charge density that can be defined as, let's take rho v. So rho v, which is equal to, I'll just add all the things like Q Nd minus Q Na plus Qp minus Qn. So here let's take the charge Q as a common and relate all other things like Nd minus Na plus P minus N. Okay, so this is what the rho v that we will be getting. So for electrical neutrality, this value we can relate to 0. Okay, then what will happen? The Q will be becoming 0. Then we can move all the positive term into one side and negative terms into another side. So Nd plus P, which will be equal to Na plus N. So this is the first charge neutrality condition that we are attaining. Please make a note of it. So let's take each semiconductor type and relate all these values. So first type that we are going to take is the intrinsic semiconductor. So intrinsic semiconductor. So these topics are not redundant topics. These topics are this kind of explanation will give you how the charge neutrality or how the charges behavior in different things. This may or may not be in your college syllabuses, but it will help you guys to understand the core subjects. So here in intrinsic, we know that there will be no donor or acceptor atom, so it will be equal to 0. So from the equation 1, we can able to get that N, which is equal to P. So from the mass action law, we can able to conclude that N is equal to P, which is equal to Ni. So for intrinsic semiconductor, we can make a note that all the charge carrier topics will be same. So let's take the second type where the intrinsic, let's take an N type material. So in N type we know that there will be only donor atom will be there. So the Na which is equal to 0. So Nd which not will be greater than 0. So this is the term we are taking. So from the equation we know that Nd plus P which is equal to N, normal N. So this will be the term. This is from equation 1. We have derived, right? So from the equation. So this is what we are getting. So from the mass action law, we can be able to derive the equation that P which will be equal to Ni square divided by N. So where we need to apply this one. So Ni square divided by Nd plus P. So if they are giving an N type and giving these values and they are asking the minority charge carrier, then we have to substitute all the formulas and all the constant values here, and we have to find out the minority charge carrier. So for this case only we are analyzing the charge neutrality and all things. So let's find the minority charge carrier here. So from this equation we can able to relate. So just apply this value here. So just apply the P in here. So let's apply the P in here. So if we apply, then Nd plus Ni square divided by N. So let's not take this one, just apply this normal N which will be equal to N. So let's make this into a quadratic equation. So N square, just cross multiply, so that will be equal to Nd plus Ni square, so which is equal to 0. So from the quadratic equation minus B, that formula minus B plus or minus B square minus 4AC divided by 2A. So that formula, the majority charge carrier divided by, which is, I am just substituting in that formula. So plus or minus root Nd divided by 2 the whole square plus Ni square. You can make a note of it. I am directly writing the end formula. So you can just apply. This is A, B, C, and you can apply those formula. Then we will be getting this term. So this is the majority charge carrier that we are getting. So this is exact calculation. So if you use this formula, then you will be able to get the exact value, not the approximation formula. So in the previous mass action also you can apply, but for the exact calculation that we have to get means, then we have to follow this formula. So if they give Nd and Ni and they ask to calculate the majority or minority charge carrier, then you have to use this formula to find out the majority charge carrier first, and then second we have to apply in the mass action law that P which is equal to Ni square divided by N. So this is how we have to find the majority and minority charge carrier in the different types of semiconductor. So here we can take another one approximation. Instead of exact calculation, we can take one approximation that if Nd is much greater than Ni. So here we can take one approximation that we may know that Nd divided by 2 the whole square will also be much greater than Ni square. So from this we can directly take a conclusion that Nd divided by 2 plus or minus root Nd divided by 2 the whole square. We are not making anything. In this formula we are just neglecting this term, that's it. So if we take a root of it, then the prox value which will be equal to Nd. So we can take assumption that N is approximately equal to Nd. So this is approximate calculation, not the exact calculation. Then we can calculate the minority charge carrier to be Nd. So this is not a exact calculation, this is approximate calculation. Please make a note of it only when it is much greater than, not a greater than, much greater than. So please follow this one. This is will give the exact formula because we have to match the options in the given in choose the from the 4 option we have to find the answer, right? So if we go with these formulas only, we may match the answer. If you directly use this approximation, then we may not get to the exact answer, then we have to struggle. So far we have saw the intrinsic and N type. So you can try the P type also. From next class I will take the P type and other some crazy facts also I will be start teaching it. So if you guys more curious, please solve for the P type and post in the comment section. I will be happy to see those things. I hope you able to understand it. What we have seen so far is that we are seeing the charge equality condition. From the charge equality condition, based upon the different semiconductor, we are applying the value. So for intrinsic, Nd and Na equal to 0. So then N is equal to P, which is also equal to intrinsic charge carrier concentration. In N type, extrinsic charge carrier concentration, the Nd will be greater than 0. So from the charge neutrality equation, we need to use the mass action law. So I am applying the P value here, that minority charge carrier, in order to replace it with the majority charge carrier, because we need to remove the 2 unknown quantity, right? So From this we are able to get the exact calculation of majority charge carrier N. From the N we can able to get the minority charge carrier of P. So if ND is much greater than Ni, then we can use the approximation here. So approximation will help some cases but not in all the cases, so please make a note of it. So I hope that you guys are able to follow. If you guys have any doubts or any clarity needed, please ping in the comment section. Thank you. Stay tuned for the next lecture. Like, share and subscribe the channel.